Hello, this is Paul from Foresight Tech. In this lecture, I will going to find the probabilities for classical probability model, which is the major models in probabilities. Most of the model is classical probability model. What is classical probability model? If each outcome or single outcome has the same chance to happen, okay, or we say it's equally likely to happen for each outcomes. What does this mean? And usually we will have this situation. For example, if this die is normal, means what? Each side is made even. That means each side has the same chance to be rolled by you. Okay, so no significant difference on each side. In this way, this is a fair model, right? And a fair model we call the classical probability model. What is unclassical probability model is not a classical probability model. For example, if I put something on this side, okay, I put something on this side, and this side will get heavy, right? If we're going to roll, and this time this side will goes down, has more chance to goes down because it's heavy, because of the gravity, right? This time. Okay, and each side does not have the same probability to happen. This is one example. Okay, in that case, it's not easy to understand, right? It's not easy to study on. So the most models is classical probability model. So how to find the probability for even in classical probability model? Here is the formula. What does this mean? And this is a fraction, and at the top is the number of A, which means number of success outcomes. We want A to happen, right? So if A happen, called successful. So this is put all the outcomes, count one by one. How many number inside the even the A? We call it the success number. We simply say the successful number. What is the bottom? This is the number of S, sample space. That means all the number, right? That's the number for all the outcomes, or the number of sample space. Okay. And the formula is super easy. We're going to find few examples. You will see. Look at the first. A sample space consists of 38 separate events that are equally likely to happen. This means it is a classical model. We see this. So there's a classical model. What the probability for each? If I say I draw a graph like this. If this is all the sample space, can you see? If this is the sample space, or the sample space, how many single outcomes? Single outcomes. Separate events means single outcomes. You can see this is a separate events is a single outcome. Simply say, how many outcome do we have? We have 38. If I just name 38, if this is 1, I put this circle, and this is 2, this is 3, that goes on. The last is outcome 38, not the number, okay? I just name them. And then we're going to look at the probability for each. If I simply look at it, this outcome, each, right, single, okay? What this? And this time, this is the successful event that we need. And with how many? In this event, how many outcomes? Only one, right? Only one. Therefore, the probability is easy to find. Okay, is the number of A over the number of sample space. Okay, what is the number A? We will have the number in A is only one, single one. What is the number in the total sample space? 1, 2, 3. Count to 38. Okay, so we have 38. Okay, this is the first. So each single outcome has the same probability. Put all together is 100%. The one more, look at this. A die is with 12 sides. Okay, of course it's not this. Okay, it's another. This normal die, that's not a normal die. Okay, what's the probability of rolling a number less than 11? Let's think about this. So I still put the sample space. Okay, if this is the sample space. I put the sample space as here. How many? Probably you can roll number 1, right? Still do this. Number 1, probably get the number 2 or get the number 3. that probably you're going to number 10, okay, and then number 11, and then number 12 size, right? The last is number 12. See, that's all. So how many in total? We can see how many in total. So this is 12, the sample size. Simply say the sample size equals the sample space, the size is 12, right? Okay. What is your interesting event? Your interesting event is a number less than 11. What is yours? See, that's yours, right? Okay, so this is your successful A. And how many you counted? The number in A is 10. And then easily to follow the formula. Okay, so the probability equals the number A over the number in sample space. And then the number A is 10, and the total is 12. Total is 12, right? But don't put this number. Simplify. Okay, simplify. What I can do? I cut 2. So this is 5. I cut 2. That's 6. Okay, it's better the last one is put it like this: 5 over 6. Okay, the simplified fraction. Or you can use a fraction function in your calculator. Look at one more. A class consists of 27 female students and 32 male students. Okay, so what is the total class number, the students number? Put them together is 59. Okay, if a student is randomly selected, what's the probability the selected student is a woman? Okay, these are simple questions. Look at this, I do this. If I say the total sample space is S, how many? We have 52, right? If we cut it into 2, so you can see this is how many. We can say women is here. How many? 27, right? If this side is men, how many? 32. So first we look at what is the total number in sample space. Add them together is how many? If I put it here, 27 plus 32 equals 59. This is the first number we need. Go to the bottom. Okay, out of 59, you want to pick a woman. So what is your interesting? Your interesting should be here, right? Or I circle like this. This is a successful event. You want this to happen. What is the number inside? Count the number. The number in A, 27 women or 27 female students. See, and the classical model tells us, so the probability is this: the number in A over the number in total is 27 female students out of 59. Okay, you cannot simplify. This is already simplified. And then one more question. One more. If a bag contains 6 red marbles, 3 blue marbles, and 5 green marbles, 3 colors in the bag, right? What the probability you will get a blue if you random pick one from inside? Randomly. You see these words? Randomly means a classic model. Okay, this is a classic. If the classicals they are the same, if I simply get this. We cut it into 1, 2, 3 parts. This is the total sample space. 6 red. Okay, so I say red marble. This is a 6, right? Blue is how many? Blue is 3. How many green? Okay, so the green one here is 5. What is the total? So we can count it now. We can count first. You can count the total. Is what? 6 plus 3 plus 5, right? Count 9 plus 5 is 14. This is the total, which means the denominator. Out of 14, you want to random pick 1 from the back to get what? To get the blue. See, to get the blue. So which one is what you want? This one is what you need. This is A. Okay, I will count the A. The number in A is 3. Easy to find. So which means what the chance? 3 out of 14. Okay, the probability now is that the formula, and then plug into the formula is 3 out of total 14. Okay, this is already the simplest. Thank you.